Hello students, in this video I am going to explain the calculations of photoelectric effect experiment for UG students. In this experiment we are finding out one, the Planck's constant, and the second one is work function. So for this we need readings with the change of frequency. What is the stopping potential? So these are the readings I got from the device. Here red color, the frequency I have taken is 4.85 into 10 power 14 hertz frequency. So in your lab, the frequency of the red color may change depending on the manufacturer. So in my device, what I have taken, the red color frequency is 4.85 into 10 power 14 hertz. Orange it is 5.08 into 10 power 14. Green it is 5.56 into 10 power 14. And for blue it is 6.06 into 10 power 14. So all this frequency is in hertz. And I taken the stopping potential for the corresponding frequencies, and these stopping potentials are in the units of volts. First, to find out the Planck's constant H, the Planck's constant formula is H is equal to slope of the line into charge of the electron. So to find the slope of the line, we have to plot the graph taking frequency on x-axis and stopping potential on y-axis. Let's start it. So the frequency we are having all 10 power 14 as the same. So into 10 power 14 I'm marking at a side and starting with 4.85 to 6.06. So I can take like it is starting with 0, 1, 2, 3, 4, 5, 6. Here we have to find the line which is cutting the negative y-axis. For that I am taking the x-axis in between. So this is how to take the frequency. And stopping potentials, the highest value is 0.744. I am taking like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Okay, for these readings, let us mark the points. It is 4.85, 0.343. So 4.85 means on rounding it, we'll get 4.9. So this is the 4.9 line. The voltage is 0.343. And rounding it is 0.34. This is our point. And the next frequency is 5.08. Rounding off, we'll get 5.1. And stopping potential is 0.486. So it is equal to 0.49. So 5.1, 0.49, the line is this one. And next one, 5.56. 0.686 and 6.06, on rounding it is 6.1, and voltage is 0.744 and rounding it is 0.74. I think you know how to round it, and depending on the values, as I not getting here the second and third decimals, so that's why I'm rounding off to the decimal over there. Mostly if we are getting the points in line, we can make it, or else we can take the average of these points, like equal distribution of our points for our line. So I'm equally distributing like this. So let me write the scale. So on x-axis we are taking frequency, right? So this distance is equal to 1 centimeter. It is equal to 1 into 10 power 14 hertz. On y-axis it is 1 centimeter is equal to, we are taking stopping potential, so it is equal to 0.1 volt. So for finding the slope, I have to take any 2 points, that is x1 y1 and x2 y2. Those 2 points should exist on the graph line. So this is one line, one point I'm taking. So any 2 points you can take. I'm taking these 2 points. This is x1 y1. This is x2 y2. So what we got? x1 y1 is equal to, what the x value? It is 4 into 10 power 14 comma y1 it is 0.2, and x2 y2 point it is x2 we got at 5 into 10 power 14 and y2 it is 0.6. So slope formula is, I think you all know, y2 minus y1 by x2 minus x1, that equal to 0.6 minus 0.2 by 5.5 minus 4 into 10 power 14, that equal to 0.4 by 1.5 into 10 power minus 14. As it is coming up, it is 10 power minus 14, which is equal to 0.26 into 10 power minus 14. Substitute in the Planck's constant formula. H is equal to 0.26 into 10 power minus 14 into charge of the electron is 1.6 into 10 power minus 19. that equal to 0.4 416 into 10 power minus 33, which is equal to 4.16 into 10 power minus 34. Units is joule second. As there is some error, we got like 4.16. And by using this Planck's constant, we have to find the work function. This work function can be calculated in two ways. One, from the graph, and also from the formula. The formula for work function is phi is equal to h nu by E minus V naught minus A, where h is the Planck's constant what we got, E is the charge of electron, and nu is the frequency for what color we are trying to find, that frequency and that stopping potential, and A is the contact potential, which is equal to 0.5 volts for my device. For your device it may vary, depending on that you have to put it. So let us find this work function for the four colors. For red color, h is 4.16 into 10 power minus 34 into the frequency of red color is 4.85 into 10 power 14 by charge of the electron 1.6 in 10 power minus 19. Stopping potential it is 0.343 and contact potential it is 0.5. So calculate this, which I got 12.61 into 10 power minus 1, that equal to 1.261 minus 0.343 minus 0.5. Here we have to write that also, 0.345 minus 0.5, which is equal to, so 1.261 minus 0.343 minus 0.5 equal to 0.418. This is the work function we got for red color. Actually, the work function will be constant for a metal. Our work function here we are finding out in the units of electron volts, because here itself we are dividing with the charge of electron. So now coming to orange, the same formula. So the Planck's constant which we got, that only we have to take. So that is 4.16 into 10 power minus 34. And for orange, the frequency is 5.08 into 10 power 14 by 1.6 into 10 power minus 19, and the stopping potential it is 0.486 minus 0.5, that equal to 13.208 into 10 power minus 1 minus 0.486 minus 0.5, that equal to 1.3208 minus 0.486 minus 0.5, which is equal to 0.342. This is also in electron volts. Then for green color, substituting the formula. So Planck's constant substituted, the frequency of green color I have taken is 5.56 into 10 power 14 by charge of the electron, it is 1.6 into 10 power minus 19. Stopping potential it is 0.686 minus the contact potential 0. On calculating this, it is 1.4456 minus 0.686 minus 0.5, that equal to 0.2596 electron volts. Then for blue color, 4.16 in 10 power minus 34, and the frequency of blue color is 6.06 into 10 power 14 by charge of electron 1.6 into 10 power minus 19. Stopping potential is 0.744 and contact potential is 0.5, which is equal to 1.5756 minus 0.744 minus 0.5, that equal to 0.3316 electron volts. Actually, the work function of these four colors should be equal, but as there are errors in the values, that's why I got different values for different colors. So for this, take the average for these four colors. So phi is equal to phi red plus phi orange plus phi green plus phi blue by 4, that equal to 0.418 plus 0.342 plus 0.2596 plus 0.3316 by 4, that equal to 0.3378. So this is your final work function. So this work function, it is in the units electron volts.